Hello, this is Shinyu and Abby. Today we will be demonstrating how to use a graph builder to make line plot, box plots, contour plots, and mosaic plots. We will be using three different sample data: airport, diameter, and the failure size. Line plots are used to compare changes over the same period of time. For the airport data, we did delay on the y and the date on the x. This line chart shows that there is an increase in delays in December 25. To make a line plot for the airport data, we go to Graph Builder, and then we drag the delay onto the y-axis, and then the date onto the x-axis, and then we clicked on line to generate the line plot. And this plot shows that there's an increase in delay around the 25th, and then it decreases again on the 26th. For the diameter data, we did diameter on the y and then the day on the x. This chart plots the average diameter measurements each day against the date. The overall average daily diameter seems to fall within the range of 4.2 and 4.6. Same way we did the airport data, we went to Graph Builder, but this time we dragged the diameter onto the y and then the day on the x-axis. For the failure size data, we did count on the y and then the day on the x-axis. Repeating the same process to get to Graph Builder, now we take the count on the y and then we drag the day to the x-axis, and then we click on the line to generate the line plot. This plot shows that the highest mean diameter of 6.82 was produced on the 1st of March and the lowest one fell on the 4th of March at 6.12. Box plots are used to show the shape of the distribution, its central value, and its variability. There are two types of box plots, the one variable and the two variable box plots. For the airport data, we did delay on the y-axis as our one variable box plot. This box plot shows that there are several outliers and that the min is 0, the first quartile is 2, the median falls in 5, and the third quartile is around 10. The max of the data is 20. To make a two variable box plot, we did delay on the y and then the date on the x as our two variable. These plots show that the median fall within 5 to 15 of the different dates. And on the 17th, 21st, and 24th, there are some outliers. On the graph builder, to make a one variable, we just picked the data, in this case delay, and dragged it to the y-axis, and then clicked on the box plot to generate it. And then to make it the two variable, we dragged the second data into the x-axis, in this case the date, to show and compare the different box plots of each day. For the diameter data, we did diameter on the y as our one variable, and this box plot shows that the min is 3.5, the first quartile is around 4, the median falls around 4.25, the third quartile is around 4.5, and the max is 5. There are a few outliers that fall outside of 5 and one below 3.5. And for the two variable, we put machine on the x to compare the different diameters of different machines. This comparison shows that the median of the different machines line up somewhat close together and fall within the range of 4.25 and 4.5. In Graph Builder, to make a one variable box plot of the diameter, we just dragged the diameter data to the y-axis and clicked on the box plot. Then to make it compare between the different machines, we took the machine and added it to the x-axis and created a two variable box plot. In the failure size data, we did the count on the y as our one variable box plot. This plot shows that the min is 0, the first quartile is around 2, the median is around 3, and the third quartile is around 4, and the max of the data is 20. There are several outliers that fall out of the range after 20. To make it a two variable, we did the causes on the x-axis. This comparison shows that the medians of the different causes fall within a very large range. The lowest one seems to be around 1, and the highest one seems to be around 25 for the different causes. Similar to the last two box plots, in Graph Builder, we did a one variable box plot on the count by dragging the count to the y-axis and then clicking on the box plot to generate it. And then for a two variable, we compared the counts of different causes just by dragging the causes to the x-axis.
A contour plot is a graphical technique for representing a three-dimensional surface by plotting constant z slices called contours on a two-dimensional format. aka given a value for z, lines are drawn for connecting the xy coordinates where that z value occurs. Here is the contour plot for the airport data. This contour plot shows the distribution of delays during each day. To build this graph, we went to Graph and then Graph Builder. We put delay on the y, day on the x, and then we click the contour button to make it a contour graph. This is the contour plot for the diameter data. This contour plot shows the distribution of the diameter produced from each machine. We created this graph just like we created the graph before. We went to Graph and then Graph Builder. Diameter is on the x, machine is on the y, and we click the contour button to make the contour plot. This is the contour plot for the failure sites data. This contour plot shows the distribution of the count produced from each process. Just like before, we went to Graph and then Graph Builder. Count is on the y-axis and I process is on the x-axis. And then we click contour to make it the contour plot. The mosaic plot is a graphical method for visualizing data from two or more qualitative variables. This mosaic chart shows the distribution of probabilities of the reason for the delay for each day. For example, on the 16th, all of the delays were because of fog. To build this graph, we went to Graph and then Graph Builder. Reason is on the y-axis and date is on the x-axis. Then we click the mosaic button to make it a mosaic chart. This is the mosaic chart for the diameter data. This mosaic chart shows the distribution of probabilities that an operator was on a certain machine. Just like before, we go to Graph and then Graph Builder. Operator goes on the x-axis and machine goes on the y-axis. This chart shows, for example, that for operator CMB, they spent about 40% of their time on machine A386, 40% of their time on machine A455, and 20% of their time on machine C334. Lastly, this is the mosaic chart for the failure size data. This mosaic chart shows the distributions of probabilities for the count on a certain day. We create this graph just as we have created the other mosaic charts, by going to Graph and Graph Builder. Day goes on the x-axis and count goes on the y-axis. Finally, we click the mosaic button to make it a mosaic chart. Thank you for watching our video.